Good morning, students. This is the second lecture of chapter 9, and today we are going to do some more practice on how to determine the centroid. Okay, so if you remember last time we did a couple of problems with the vertical strip, vertical element, right? So today, this problem 9-9 of your book, this is we are going to do this with horizontal element, so that you are familiar with both vertical and horizontal element, right? And it depends that whichever is easier, you can resort to that method. All right, so this is problem 9-9 of your book, and we have this this area, and the equation is given for this area. The function is y equals 1/4 times x squared. Okay, so this is the function for the curve of this given area, and you can see that this is your x-axis, this is your y-axis, and we have this shaded area, and we want to find out the centroid. Okay, so let's do it by horizontal differential element. So let's take a horizontal element, a horizontal strip with the thickness of dy. So here's your thickness dy, and the length of the element is x, right? So that's how you got this horizontal differential element from this area. Okay, now we have the centroid of this horizontal element. So centroid is right here with the coordinates of x bar, y bar. Now remember, these x bar and y bar are for this element. It's not for the whole area. For the whole area, we have other x bar, y bar. Okay. All right. So now we got these. Now the coordinates of this point are x and y, right? And so this guy is y, right? And this guy, we already know that this is x. Okay. All right. So now we got everything what we need. So now we can come back and apply the equations. Okay. So first of all, let's find what is the area, dA. So what is the area of this horizontal differential element? So it's x times dy, right? So thickness times the length, x times dy is your area of this horizontal element. Okay. Now x bar equals x by 2. We know that, right? X bar is the centroid of this horizontal element. So this equals x by 2 because it will be right in the center. Okay. And y bar equals y, right? Because we have taken y distance up to the centroid of this horizontal element. So that's why we get x bar equals x by 2, y bar equals y. Again, remember that these x bar and y bar are for the element. Okay. Now we are given this function y equals 1/4 x squared. So we can find out the value of x from here. So we get x equals 2 times y to the 1/2. Okay. All right. So now we have the value of x. We have the value of the area of the element, and we have x bar and y bar of the element. Okay, so now we can apply the centroid equation, and we can find out x bar and y bar for the area. Okay, so let's go for the x bar of the area. Now here's the equation for x bar of the area. So we have integral of x bar of the element times dA divided by integral of dA, right? So just put in the values. What are the limits? We have the limits from 0 to 4, right? In the dy direction, y direction, we have the distance from 0 to 4. So we'll take these limits, 0 to 4 meters, and then we have x bar of the element. So x bar of the element is x bar of the element is x by 2, right? X by 2. So we'll do 1/2 times x. Now what is x? X is 2 times y to the power 1 by 2, right? This guy. So this is your x. Okay, so we got x, and then we have dA. Now what is dA? dA is x times dy, right? So again we got an x and we got a dy. So we got a dy. Okay, so now in the denominator, what do we have? We have the integral of dA, integral of the area of the horizontal element. Okay, so what is the area of the element? Area of the element is here. We have x times dy, right? So we'll just put in the value of x times dy. Now just remember that we are doing everything in terms of dy, right? So all right, so we got this integrals done. We'll just simplify these, and we get here in denominator we have this. So now with this we'll just apply the integrals. So 2 times y, so we'll get this 2 times 1/2 of y squared. Okay, and in the denominator we have 2y to the 1 by 2, so we'll get 2 times 2 by 3 times y to the 3 by 2. Okay, and we'll apply the limits 0 to 4 to both the values, right? And we'll get this 4 times square, 4 square divided by 4 by 3 times 4 to the 3 by 2. Okay, and from here we get this x bar as 1.5 meters, right? So now you can come back here, you can come back and now see x is 1.5 meters, right? So 1.5 meters, so this is 4 meters, so this is 1.5, 2 meters, let's say 1.5 somewhere here. Okay, so let's say somewhere here, this is your x bar. Okay, so now let's go for y bar. All right, so y bar, we know the equation. What is the equation for y bar? It's the integral of y bar of the element times dA divided by integral of dA. Okay, so just put in the values. Y bar, we know what is the value of y bar. Y bar equals y, right? And y equals 1 by 4x squared. Okay, so we'll just put in the values. Y bar times dA, so we'll get y times 2y to the 1 by 2 times dy. Okay, divided by dA, so we'll have the area dA, which is x times dy, right? So just put in the value x times dy. Okay, just simplify this to apply the integrals. You get these values: 2y to the 3 by 2 divided by 2y to the 1 by 2. Okay, so with this, just apply the integrals, okay, and apply the limits. So we'll get this. Once we apply the integral, we get this at the top, and the denominator we get this value. Okay, and we have these limits 0 to 4 and 0 to 4 over here. Okay, so now we have these limits, so just apply the limits. In the top we get this, and the denominator we get this. Okay, just simplify these limits, we get these numbers, and if we simplify this, we get y bar as 2.4 meters. Okay, now come back and see where is 2.4 meters. So this is 4 meters, this is the center line, 2 meters, so 2.4 would be somewhere here, right? Okay, so now just join them. This is your centroid, x bar, y bar. Okay, which looks right. So which looks right, and with that we can say that okay, we are going in the correct direction, and our answer seems right. Okay, so that's how we get our centroid x bar as 1.5 meters and y bar as 2.4 meters. All right. Okay. So with this, we are done with this problem 9-9. Okay. And now, next we are going to do two problems. One, the same problem, first with the vertical element and then with the horizontal element. Just to make sure that we know that whichever method we follow will have the same answer, right? Either we follow the vertical element or the horizontal element method, but we'll get the same answer, right? So this is example 9.5 of your book, right? And this is the curve. Let's make it here. Okay, so this is like this. All right, and this is XY. Okay, so this is the given curve, the shaded area, and we want to find out the centroid of this curve, right? Again, this is example 9.5 of your book. Okay, so first we are going to do this with vertical element. Okay, so let's suppose we take a vertical element, right, as shown. So this is the vertical element which we are considering in this area. Okay, so with the length of dx, so this is the length or the thickness, let's say thickness dx, and the length, so vertically let's call it a length, so a length of y. Okay, all right, so this is okay. All right, so length of y, thickness of dx. Now let's assume that it has a centroid right here, and centroid has these coordinates x bar, y bar, and these x bar, y bar are for this vertical element. Okay, all right, so now let's take this distance as x. Let's take this distance as x, the centroid of this vertical element, and this is the length, which is y. Okay, all right, so this is not working well. Okay, all right, so now we have all the things which we need. So we are done with the vertical element. Now let's find out the area, dA. What is dA? dA is the thickness times the length, so dx times y, right? So let's say y times dx, or dx times y. And we know what is the function for the curve, which is y equals x squared. So just put in y equals x squared. So we get x squared times dx as the area. Okay. All right. So now we have this. We also know that x bar equals x, y bar equals y by 2, right? We already know that. Okay. So now we can apply the centroid equation. What is the centroid equation? Let's apply for x bar first. Find the x coordinate. We have this guy here, integral of x bar of the element times dA, and in the denominator we have integral of dA, which is the area of vertical element. Okay, so just put in the values. Limits will be 0 to 1 because we are going with dx with the vertical element. So we have 0 to 1 is the limit in the x direction on the x-axis. All right, so just put in those values. Limit is 0 to 1, x bar, put in the value of x bar, and dA, we get x times x squared times dx, right? In the denominator, we just have the integral of dA, right? So the limit will be 0 to 1, and inside the integral, we have x squared times dx, which is the area of the element. Okay, now just simplify these things. Simplify these integrals and take the integral. So if you take the integral, you get this 1 by 4 times x to the 4. In the denominator, we have 1 by 3 times x cubed. Okay, and now we need to apply the limits 0 to 1. Okay, So if we apply the limits, we'll get 1 by 4 divided by 1 by 3. Okay, so if you do that, you get this, which is your x bar of the area. So x bar of the area is 0.75 meters. Okay, all right, so we got one coordinate of the centroid of the area. Okay, now let's go for y bar. All right, so this is your y bar. Y bar, same equation, we need to use integral of y bar of the element times dA divided by integral of dA. Okay, so let's do that. Just put in the values of y bar and dA. Right, limits would be 0 to 1 because we are going towards we are taking dx, so we are moving in the x direction, so we have the limit 0 to 1. Okay, and y bar times dA, we get this, y by 2 times x squared times dx. In the denominator, we have inside the integral x squared times dx, which is the area. All right, okay, so I just simplify this, you get this 1/2 times x to the 4 times dx. And denominator, we have x squared times dx, the same value. Now just apply the integrals, we get this 1 by 10 times x to the 5. Denominator, we have 1 by 3 times x cubed, right? And just apply the limit 0 to 1, we'll get 1 by 10 divided by 1 by 3, right? And just simplify that, you get y bar equals 0.3 meters. Okay, so y bar equals 0.3 meters. Now this is the y coordinate of the centroid of the area, right? So x bar 0.75, y bar 0.3. Let's just plot this point, plot this centroid on the actual shape. Okay, so x bar 0.75 meters would be, let's say, somewhere here, right? Somewhere here, x bar 0.75, y bar is 0.3. So y bar somewhere here, right? 0.3. Okay, somewhere here. So where these two meet, this guy, this is the centroid, right? This is your big C, centroid of the area. Okay, so if you look at the figure, if you just visualize the given area and the centroid which we have found, so it looks to be right? Because this looks to be the center of the this area. Okay, so that's why we can say that okay, we seems to be right. Okay, all right. So now we'll do the same example 9.5, the same problem which we just did with the vertical element. Now we'll do that with the horizontal element. Okay, so let's do that with the horizontal element. Okay, so this is the same problem, same curve which we already did. The function for the curve is y equals x squared, right? The same function which we did in the last problem. Now let's take the horizontal element. So let's take this element, this guy, and let's solve with this. So now the thickness is dy, right? And now it's here, so we can say that the distance x is the start point of this element, right? So this is, let's take this as x, let's take this as y, right? Y is the distance until the centroid. Okay. Now the centroid of this element is x bar, y bar, right? X bar, y bar, and the start point of this horizontal element is xy, right? Because this guy is x and this guy is y. Okay. All right. So now we have everything done. We need to do a little more for this horizontal element. So you know that from this point till this point, right, distance is 1. Now we are taking this as x, so what is this guy? This guy, the balance length of this area is 1 minus x, right? So this is 1 minus x. Now what is x bar? This guy, x bar, which is the x coordinate of the centroid of this element. Okay, so let's do that. Now we know that this is, we have 1 minus x and we have x. So what is the value of x bar of the element? It will be this x plus 1 minus x divided by 2, right? So we can write this equation: x plus 1/2 of 1 minus x is the centroid of the x coordinate of the centroid of the horizontal element. Okay, so now we got everything done. So now we can go ahead and apply the equations, right, to find the centroid of the area. Okay, so to do that, first we need to find what is the area. Okay, so let's find what is dA, or what is the area of the horizontal element. No, it's dy times 1 minus x, because 1 minus x is the length and dy is the thickness. So this is the area dA of the horizontal element. Okay, now what is y bar? Y bar equals y, right? So we already have this from the figure. Now what is x bar? X bar, we know that x bar is this guy, x plus 1 minus x divided by 2. Okay, if you just simplify that, you'll get 1 plus x divided by 2. Okay, so this is your x bar. Now we can apply the centroid equation, how to find the centroid of this area. So first let's go for x bar. Let's go for this guy, x bar. We know the equation by now. At the top we have the integral of x bar of the element times dA. In the denominator we have integral of the area of the element. Okay, all right, so just put in the values for x bar times dA. We have this, right? 1 plus x divided by 2 times 1 minus x times dy. So this is the equation at the top, and at the bottom we have 1 minus x times dy, just the area of the element. Okay, so now just simplify this. We can take 1/2 outside, because that's a constant. Inside we have 1 minus x squared times dy. Denominator we have 1 minus x times dy. Okay, all right, so now we can just say that this x squared, just put in the value of x squared, we have y, right? Because we have dy here, so we need everything in terms of y. Okay, only then we can apply the integrals. And in the denominator, just put in the value of x, which is x is square root of y, right? Which we got from this function. So we have this y equals x squared, so x squared equals y, or x equals square root of y. Okay, all right, so now we get this. Okay, all right, so now just apply the integrals. We get this. So apply the integrals, you get this at the top, and denominator you get this. So I'm sure that you all know how to apply the integrals, so we don't need to go into the details of integrals. Now you just need to apply the limits, 0 to 1 at the top, 0 to 1 at the bottom, right? So just apply these limits. We get this at the top and we get this at the bottom. You just simplify, you get this, and you get x bar equals 0.75 meters, right? Now if you come back with the vertical element, we got x bar at 0.75 meters, right? So we got the same answers for x bar. Now let's go for y bar. Okay, so let's go for y bar. We know the equation. At the top we have y bar of the element times dA. Denominator we have integral of the area dA of the element. Okay, now just put in the values. We get y times 1 minus x times dy at the top and 1 minus x times dy at the bottom, right? Okay, so just simplify, put in the values of x here because we need everything in terms of y because we are taking integral with respect to y. Okay, so just put in those values. We get this here, we get this here. Okay, now just apply the integrals. So this is the final shape and we'll apply the integrals here. So after applying the integrals, we get this guy. Okay, this guy at the top, this guy in the denominator. Now we can apply the limits. If you apply the limits, you get this. This is in the denominator. This is the overall fraction. And you get y bar as 0.3 meters. Okay, so you get this y coordinate of the centroid of the area. Okay, now let's come back and see what did we get in the last problem with the vertical element. So y bar as 0.3 meters, right? So which means that we have done it correctly and we got y bar as 0.3 meters, x bar as 0.75 meters, right? So now this x bar, y bar is the centroid of the area. Okay, so that's how with this example, doing it with both the methods, with the vertical element and with the horizontal element, we can say that any problem involving the centroid of the area, right, can be solved with the horizontal element or the vertical element, right? So in some cases, the vertical element is easier, and in some cases, horizontal element is easier, right? It depends on the type of problem. So that's all about today's lecture. We did 3 problems on the centroid, and in the next lecture, we'll start with the next topic. All right. Thank you.